This lecture will give some more examples of Internet of Things devices, just to give you a sort of a better, more concrete idea of what these devices are and how they differ and how they're distinct from traditional computers. So we'll run through a few more examples and give a little bit more detail about their behaviors. So take a car. A car is an IoT device, I will claim. Okay? The reason I call it this is because if you look at a car, it's a thing, clearly. You look at a car, an old car, there's an old car, a 50s car maybe. So old cars had a certain interface, right? You have a steering wheel, gas pedal, brakes, and so on, the radio, sort of a simple, straightforward interface, what I would consider to be simple. Now that interface, it was basically implemented with electrical and mechanical controls, but there was no computational intelligence in there, right? Early cars, they didn't have computers in there, processors doing anything. There was electricity, there was mechanical stuff, but that was it. So that's an original device. It's not IoT from the 50s. But nowadays, cars have lots of computational intelligence. Let's take a look at this. So 21st century car. So what is that? It looks like a Prius, I think. This car, it's got lots of chips in it, so lots of processors. That car might have over 50 processors in it doing different tasks. For instance, it's got an anti-lock braking system. They all do these days. And the anti-lock braking system, it'll have its own processor dedicated just to anti-lock braking. And so it's got that. It's got fuel injection, right? Fuel injection system. It's going to have another processor dedicated to that. So every subsystem has its own processor. And it's also got a stereo, say. Stereo system's got to have its own processor. But every subsystem inside the car has its own processor. But the thing about this car that you notice about this device is that even though it has this computational intelligence, it has the same basic interface as that 50s car. So you drive this car pretty much the same way. Now the 50s car, it probably had manual transmission, I'm going to guess, because it's the 50s. So this will have automatic transmission. But besides that, it has the same interface, the same steering wheel, gas pedal, brake. So you could train somebody to drive on the 50s car and they could drive this new car. Even though this new car is enhanced with all this computational intelligence. So that's the thing about IoT devices. They have a very simple interface. They want to be easy to use. They want to give you the benefit of this computational intelligence. So now you have anti-lock braking, for instance. Now anti-lock braking, in case you don't know, anti-lock braking, it prevents the tires from locking. So you always want the tires to, you don't want the tires to skid compared to the road, right? They should always stay in good contact with the road. But if you brake hard, if you're moving fast, you brake hard, the car will skid and the tires will not move, but the car will move, right? So anti-lock braking tries to prevent that. Now, before anti-lock braking, what you used to do, I remember when I learned how to drive on snow, you skid a lot, right? So what you do is when you do a hard brake, you'll pump the brakes, right? Manually pump the brakes. Now, and you'd have to remember this. You have to be pretty consciously aware enough to remember to do this. Anti-lock braking do that for you, right? Anti-lock braking devices, they take care of that for you. So this is a great benefit to drivers nowadays. Kids don't even know about pump and brakes. They don't learn that because they don't have to. Anti-lock braking takes care of it. So the computational intelligence is helping you, relieving you of burdens that you didn't want to have to deal with. But the interface is beautiful. You don't have to worry. You just hit brake pedal just like you used to. It just does better. It just does what you want it to do, does better, and makes everything easier for you. Now, a typical car, this car that we're looking at right here, this car, it has computational intelligence. Now, whether or not it has networking is a different thing. These cars nowadays, actually these days, cars are having more and more networking. And you may have heard of this in the news, but cars are networked actually. So you can, for instance, remote start a car, right? Start it when you're not near the car. You can start it through the network. Cars also have the, what do they have in there? Those, I forget the name of the brand. There's OnStar is one brand name. But when there's an accident, the car can, through the internet, connect with 911 and call and get help, right? So this type of thing is present in cars. My car does not have that, but I'm cheap and I'm a professor. I buy old cars. So my cars are old, but new modern cars have these features built in there and they are actually networked. So that would be a modern car, the most modern car, that would be an IoT device because it has the computational intelligence and it's also networked to add extra flexibility. So that's one device. Let's take a look at another. Let's talk about logistics, tracking things, okay? Logistics. So say you are Walmart or some big company, or you're the military, something like that, and you want to move lots of things between different places on a certain time scale, right? You need to get these from this manufacturing place to this sales place on this schedule. That's logistics. And the military is all about logistics, right? We are waging a war. We need to get these devices from here to here and these people from here to here on this time frame. So you want to move things. So say you're Walmart, and you want to, you would have to be able to track these devices that you're moving. You want to make sure that they are moving from place to place in a certain time frame. And you want to be able to, at any time, be able to say, where is box number whatever, right? How many boxes do we have of this type of device at this location at this time? And you need to be able to track that dynamically. So you can account for things like weather difficulties, right? Maybe the planes are shut down, so you can't move enough devices from here to here. So you need to know how many are here so you can reroute things. So to do that, one way, a very common way, is to use barcodes, right? This helps you because every box, every device, it has a barcode which has some basic information about what's in the box, right? And where the box came from, stuff like that gets stuck on the box. Now barcodes are in very common use today, right? We use barcodes. If you look at any food item, you go to a supermarket and you check yourself out, you run the barcode over the scanner, right? So barcodes are very useful, and they have a certain amount of information on there, and they make it so that you can just scan the device and find out information about the device or whatever it is, the box, and it makes it easier to track. So this is basically old technology. Barcodes have been around for a long time. Nowadays, you also find RFID tags. So RFID tags, you can see the antenna for one right there. It's basically an electronic version of a barcode. And what you're seeing is that sort of spiraling wire. That's actually the antenna, okay, a remote antenna. And what RFID tags allow you to do, why they're an improvement over barcodes, is the first thing is they basically have a processor inside there. So you can have a lot more information about the device than what you could encode inside a barcode, right? A ton more information. And that information can change, right? Because barcode, once you print that on the box, that will never change, right? Until you rip off the barcode, put a new barcode on. But that data can never change. With an RFID tag, that thing can have flash memory in there if you want to, that actually reloads, that gets changed and updated over time. So for instance, if you want to track where a box moved, the box itself, its RFID tag can store that information over time. So as it moves from place to place, you can store that and you can see the whole path that the box took. Right? So RFID tags, another benefit of these is that you don't have to be right next to them to scan them. So if you know anything about a barcode, you have to take a scanner, put it right up to the barcode in order to scan it. And you have to try, right? You have to, if you ever scan, like just yesterday, I was at Albertsons scanning food out. I have to work to get that scanner directly over my barcode, right? With RFID tags, there's a range. So you just have to be within proximity. You don't have to have any particular orientation, just be near it, which is helpful, right? Then you can just run every box near a scanner and it'll catch it. So RFID tags have a lot of advantages over barcodes, and they can easily be networked. So the scanner can be networked, connected to the internet, so you can keep constant track of where all your boxes are at some global site. So Walmart can know where every box is, in what manufacturer, what plant it's in, and they can keep it all centrally because the IoT RFID scanner is actually connected on the network to its main cloud servers. So devices can become an IoT device if you put RFID tags and the computational intelligence onto them. Thank you.